synchronization and how to synchronize a method and how to synchronize a static method and what are the laws that are applied when we synchronize a non-static method and as well as a static method and how we can synchronize some particular statements inside a method. Okay? And the next thing, today we will be going to discuss the producer consumer model. Producer consumer model. Okay. In the producer consumer model, okay, we have a producer, where producer will produce the products. This comes like this is the product. The producer will be there. The producer will produce the products, and the products will be there in queue. Okay. And the producer is a thread. Producer is a thread which continuously produces the products. Producer is a thread which continuously produces the products. Okay? And the products will be sent into the queue. Next comes a like, okay? The queue size is 10. Next comes like a producer has produced 10 products. Producer has produced 10 products. Now, is it a correct thing to produce a 11th product? Is it a correct thing to produce a 11th product? No, just because already the queue is full and we cannot place the product in the queue. Since the queue is full and we cannot place the product anywhere, it's not correct to produce a producer. Okay, it's not correct to produce another product. So just because we cannot place that in the queue, we cannot place the product in the queue just because the queue is full. So what we do is, we have another thread which is consumer. What is consumer thread will do means, okay, the consumer thread will continuously fetch the products from the queue. The consumer thread will continuously fetch the products from the queue. So it will fetch the products. Okay, let's select there are 10 products and the consumer thread is continuously fetching the products from the queue. Let's consider that now the queue is empty. The consumer has fetched all the products from the queue and currently the queue is empty. Now, if the queue is empty, is it correct to make the consumer alive? It's It's not correct to make the consumer alive if the queue is empty. Okay? If the consumer is still fetching products from an empty queue, is it a correct thing? No, it's not a correct thing that if a consumer fetches some products from an empty queue, it's not a correct thing. Okay? So when the queue is empty, what we need to do? We need to block the consumer thread for some time. When the queue is full, we need to block the producer for some time. But we don't know when the queue is full and when the queue will be empty. Now in that case, can we use sleep to make the thread to block space? Can we use, in this case, can we use sleep to send the thread to block space? In this, let's consider like the queue is full. Let's consider like the queue is full. Okay? Now, if the queue is full, okay, is it correct to make the producer thread alive? If the queue is full, there is no use of producer thread for at least for some time. Okay? Now, we need to send the producer to the block phase. Now, in this case, can we send the producer to block phase using sleep? Is it correct to send the producer thread to block phase using sleep? Yes or no? Is it correct to send the producer thread to block the phase using the sleep method? Is it correct? No. Or else? It's not at all correct in this scenario to send a thread using sleep. Just because the producer should be reactivated whenever the queue is empty. But can we guarantee the queue will be empty in 10 seconds or 20 seconds? No. So, in that case, we should not use sleep. We should use the wait notify mechanism. Wait to send the producer to block phase and notify to reactivate the producer. Okay? Like that. Okay? If you want to perform some wait or notify, if you want to perform some blocking or reactivating a thread based on some conditions, then we should go for wait and notify. Wait for blocking the thread, notify for reactivating the thread. Let's consider like there will be some process and we assume that the process will be completed within a second. So let's consider 1 second means 1000 milliseconds. So what we do is we block the process for 1500 milliseconds so that we can make sure that the process will be completed. Okay? So that kind of things can be expected. Let's consider like there is a file with which is of size some 1000 lines. We can expect that the Java application will read that file in maximum 1 second. So we can, at that scenario, we can go for a sleep. But since this involves multiple things, this involves a producer thread and adding the products, produced products to a queue, and a consumer which continuously consumes the products. Since this involves all these things, we cannot expect the time-based mechanism. We cannot perform blocking or reactivating based on the time in this case. But let's consider like we know that a file contains some 10,000 lines, and to read 10,000 lines at maximum in any workspace it will take 500 milliseconds. So what we do? We will make a sleep of 1000 milliseconds. So that what happens? Within 1000 milliseconds, will read the 10,000 lines from the file. So in that scenario where the time has some boundary, we can expect them and we can go for sleep. But in this scenario, we cannot go for sleep. We should go for wait for blocking the thread and notify for reactivating the thread. Understood? Let's see the first thing how understood this model, like what is producer, what is consumer, and what is a queue. Okay? Now a producer is a thread, consumer is a thread, and the queue will be a collection. Queue is a collection. The producer here, it is a thread, and the consumer is a thread, and the queue will be a collection. Okay, now let me give a simple example where sleep can be used to send a thread to the block sales. Guys, let me copy the whole program. Now I have removed all the stuff. Okay, now let's consider that just in the main method I have 2000 lines to be executed. Okay, 10,000 to 12,000, and in the first thread let me have some 1000 lines to be executed. In the first thread, let me have some 1000 lines to be executed. In the main method, I have some 2000 lines to be executed. Now, okay, what I am doing is thread dot current thread dot sleep. I am making the main thread to sleep for 500 milliseconds, so that within that time, this 1000 lines will be definitely executed. Okay, if I have some expectations like that, then we can go for sleep. Just sorry, try the catch with number. Now go to the classes. So if you see here, first main thread is started and the child thread is also started. Okay, then what happened is, if you see the output here, first the first thread is started, right? First thread is started and first thread has executed some statements. Sorry, the first thread has executed some statements, and after first thread executing some 300 statements, then the main thread is activated. Okay, that means within 500 milliseconds, this first thread has executed some 300 statements. Okay, within 500 milliseconds, this first thread has executed 300 statements. Okay, till then is the main thread activated? No, the main thread is not activated up to that time. Then after executing some 300 statements, then the main thread is activated. Okay, and the main thread and child thread are parallelly executed. So just if you increase the sleep time to 1000, okay, and see. Compare, go to the classes and execute the application. So if you increase the sleep time to say some 1000, what happened? Still it is increased to 630. Okay, so like that, based on the number of executions that we want to do for child thread, we increase the sleep time. Okay, and we'll fix some maximum sleep time so that definitely some other thread will execute the process within the sleep time. Okay, like that. Okay, if we have some fixation like this process will be completed at maximum within this number of milliseconds, then we go for sleep. But in case of producer consumer model, we cannot have such fixation that the producer or the queue will be empty at this time or within this number of milliseconds, or the queue will be full within this number of milliseconds. So since producer consumer model doesn't have that kind of fixation of time, we should go for wait and notify to deactivate as well as reactivate the threads. respectively. So let me show you a simple example which uses a wait notify mechanism, okay, to achieve this producer consumer model. Now let me write a class with a package. Likewise, we can send any thread to sleep phase. Like if you want to send the first thread to sleep phase, just I can send very easily T1 dot sleep. So that now the child thread is sent to the sleep phase. Sorry, this will not be the case just because sleep is a static method. Okay, sleep is a static method, and even if you use a reference at the runtime, it will be converted to this thread dot sleep. So the currently executed thread will be sent to the sleep phase. Okay. If you want to send this to the sleep phase, what we can do is if I equal to 500, after executing some 500 statements, I want to send the child thread to the sleep phase. So what I'll do is when I becomes 500, just I'll send this thread, the child thread to sleep phase for 1000 milliseconds. Understood? See, we can use this in send the thread to sleep phase using thread.sleep. Okay, and the only currently executed thread will be sent to the sleep phase. So, if you want to send this first thread to sleep phase in the run method, just we execute this code. So, just we can send the thread to sleep phase, sorry, using thread.sleep. So, for some time, only main is executed. Okay, see, within this gap, only main is being executed. Okay, just because at that time the child thread has sent to the sleep phase. Okay, the child thread has been sent to the sleep phase, so that within this gap, only main thread is being executed. So we can set any thread to sleep phase using thread.sleep, and the currently executed thread will be sent to the sleep phase. Understand? And this is how we can use sleep to send the currently executing thread to the block space. And how we can use wait in Notepad, let us see. Let me have Just for temporary purpose, I am extending to thread class, but it's not the ideal way. We should implement with runnable. Okay. Just for simplicity, while giving a demo, just I am extending to thread class. ArrayList is a class in Java util package. I'll explain what is ArrayList, but just make it a note. I'll explain in depth what is ArrayList, but make it a note like this is the ArrayList. Just I am specifying that I am using a collection of products. Okay. Just this is the reference product list, and array list is used to represent a collection of products. Yes, I am adding a method add products to queue. Okay. Yes, I am adding the products to the queue. Okay. Now just I am fixing why final static attributes are used. Final static attributes are used as constants, and all the constants in Java should be in uppercase, separated by underscores. The maximum queue size is 10. Okay, so there is a method size in any collection. In any collection, we have a size which represents the size of the collection. Now, let's consider like there are 10 products in the collection. Okay, then the product list size is 10. So I am verifying if the maximum queue size is not equal to product size. If the maximum queue size is the product size, what happens? The queue is full. Okay. If the maximum queue size is the product list size, the queue is, that means the queue is full. So when the queue is full, we should not add products to the queue. Okay, otherwise else when it comes to the else, when it comes to the else block, when the queue is full, when the queue is full, it will come to the else block. Otherwise, I'll make it. Now, when it comes to the else block, until the queue is not full. Okay. If it's true when the queue is full, when the product list size is equal to maximum queue size, then the queue is full. Okay, or make it greater than or equal to the queue size, or you can make this condition. It's better. If the product list dot size is greater than or equal to maximum queue size, then the queue will be full. Okay. If the size of the collection is greater than or equal to the maximum queue size, then the queue will be full. When the queue is full, what we do is we send the thread to wait phase. We send the currently executing thread to wait phase. Now, are we executing wait method? Okay, are we executing wait method by using a thread class reference? Are we using the wait method using thread class reference? No. Are we executing? See, earlier we used to execute all the methods related to this using the thread class references, like okay, t1.setName, t1.join, set priority, like that. We used to execute all the methods using thread class references. Right now, are we using the thread class references to execute wait? No, we are not using the thread class reference to execute wait. Okay, a very important interview question will be, okay, see, we have a thread class to represent the thread method. Then why wait, notify and notify all? Why wait, notify and notify all are not there in the thread class, are there in the object class? See, wait, notify and notify all are used in multi-threading mechanism. If they are used in multi-threading mechanism, why those wait, notify and notify all are there in the object class? Why they should not be there in the thread class? That's a very important interview question. Okay. Now, using which reference we are calling the wait method here? Are we using any references to call the wait method? Now, on which object we are calling the wait method? Which object's wait method we are calling? This current object's wait method. What is the current class? Product queue. So we are calling the wait method on product queue. What is the product queue there? Is it a shared resource between two threads? Is the queue shared resource between two threads? Yes. So we execute wait method or notify all on the shared resources, not the threads. So shared resource, is it required to be a thread, or is it mandatory for a shared resource to be a thread? No. So since we execute wait, notify and notify all on shared resources, the wait, notify and notify all are there in the object class. Just because shared resource can be any class. So if they are placed in the object class, then they can be inherited to any of the classes. If they are placed in thread, what happens? We are enforcing the shared resources to be threads, which is not a correct thing. So those wait and notify all, even though they are methods used in multi-threading, okay, they are supposed to be executed in shared resources. Since they are supposed to be executed in shared resources, which can be any class, which can be any class, those methods are generically kept in the object class, so that they will be available for any classes. Understood? Why wait, notify, and notify all are there in the object class, even though they are involved in multi-threading? Understood, everybody? Got the clarity? Yes? So this wait, notify, and notify all should be executed from the shared resources. Then which thread will be blocked? See, we execute wait from shared resource. The shared resource can be accessed by 100 threads. Which thread will be blocked? How you can come to know producer thread will be blocked? Just because it is a synchronized method, at maximum only one thread can come into the synchronized method, and the currently executing thread will be blocked. See, is there a possibility that multiple threads can enter here? No. So, only the currently executing thread will be blocked. And at most possible, we should use wait, notify, and notify all only in synchronized methods. Okay? We should use them only in synchronized methods. And the execution of this wait or notify all will raise a checked exception, which is interrupted exception. So we should handle the interrupted exception. Just I'm trying to compile this where it is expecting some semicolon. See, it's telling that unreported exception, interrupted exception, which is a checked exception. So wait method will raise a checked exception, which is named as interrupted exception. So let me catch the exception. So wait, notify, and notify all will be used on the shared resources. And which thread will be blocked means the currently executing thread will be blocked. Now let me add another method. Consume products from queue. If product size is equal to 0, what happens? If the product list size is equal to 0, then what is the scenario? The queue is empty. So when the queue is empty, then we need to send the currently executing thread to the wait phase. Okay? We should send the currently executing thread to the wait phase. Otherwise, we need to notify the thread. You need to notify the thread and just I'm printing the consumed product. First I'm removing the product from the queue. Okay? I'm removing the product from the queue and I'm printing the removed consumed or removed product from the queue. Just remove of 0 means remove the first product from the queue. Okay? Now let me write a run method in the producer. And let me override a toString method in the product first. ID and colon? No. So in the run method, what we do is we write a for loop for 30 times. Let me have a reference of Q with the producer. So what we are doing, we are continuously creating a product, okay, and I am adding the product to the queue. In the run method of the producer, I am continuously producing the products in a for loop where it has 30 iterations, and I am adding the product to the queue. I'll do the same thing in the consumer also. In the run method, what we do is just we'll consume the products from the queue. Okay, let me explain once again from the first. First, we have a product which has a product ID and product name. Okay, understood? Now we have, let me write it here. We have a product which has a product ID and product name, and we have a queue. Okay, which contains a list, which represents the product queue. Okay, and we have a maximum queue size, and we have two methods in the product queue. In the queue we have two methods, one method to push some elements into the queue, one method to fetch the elements from the queue. Okay, one method to produce the elements into the queue and one method to consume the elements from the queue. Okay, and this method will be accessed by the producer and this method will be accessed by the consumer. Okay, and can the producer and consumer access the same method at the same can the producer access this added products to queue and the consumer access this consumed products from queue at the same time? Is it possible? Is that scenario possible? Can the producer access this method and can the consumer access this method at the very same time? Is it possible? No, just because these two are non-static synchronized methods and only one method can be executed at a time and only one thread can execute this product queue at a time. Okay, and now what we are doing is in add products to queue, first I am verifying if the product size has reached the maximum queue size or not. If it has reached the maximum queue size, then I am sending the current thread. Then which thread will be accessing this method? Which thread is accessing this method? Producer. So the currently executed thread means the producer thread. So when the queue is full, producer will be sent to the wait phase. Otherwise, if it has been sent to the wait phase, it will be reactivated. Okay, then we'll add products to the queue. Okay, and if you see other method, consume products from queue. If the queue is size is 0, that means if it is the size is 0, what it indicates? It is empty queue. If it is empty queue, then we are sending the consumer to the wait phase. Otherwise, we are notifying the consumer thread and just we are removing the products from the queue. We are consuming the products from the queue. Again, we are writing a thread which contains the reference to the queue. Okay, and to the queue we are continuously adding the products. Okay, and even the consumer from the queue we are continuously consuming the products. Understood what we have done? Understood everybody? Now let me try to execute this application. Sorry, even in 40th line also. I need to put this in try catch. Let me copy this. Whenever we are sending a thread to active from active to blocked phase, we should keep it in a try catch. Whatever the method might be, either sleep or suspend or wait. If we are sending a thread from active to blocked stage, definitely we should handle the interrupted exception, which is the checked exception. So now it was compiled. No. Now producer consumer model was compiled. Clear the screen. Go to the classes and execute the application. Again the first thread, second thread. Why the first thread and second thread? Sorry, I have been executing the other class which is thread demo. Now let me execute. producer consumer model. Okay, no class producer consumer model. Hey, we did not write anything in the main method, so first we'll create a queue. And we create a producer. We create a consumer. By sending the queue, and we start the producer, and we start the consumer. Okay, this I have created a thread and I have started the thread. Now let me go to the source again. Let me try to compile the applications. Cannot find symbol consumer. Let's compile. So let me go to the classes to execute. So first, okay, it was like this. Now what I'm doing is, even while producing the product also, let me give some system.out.println. Just adding the product P. See, first what I am doing is, I am continuously adding the products to the queue. Okay, I am continuously adding the products to the queue. Okay, is the consumer activated until the product is full, or until the queue is full? Until the queue is full, the producer will not leave the queue. The producer will not leave the queue until the queue is full. When the queue is full, what happens? Is the producer now available? No, the producer is not available. Then the consumer will be coming to the picture, and the consumer has consumed 2 products. Okay, and again parallelly the consumer has been sent to the blocked phase. Again the producer is activated. Again the producer is activated just because it has the queue is not full and it has the ability to produce some products. So again the producer is continuously producing the products and the consumer is continuously consuming the products. But at one point of time, okay, the producer has stopped producing the products just because we have kept a for loop only to produce how many products? 30 products. So producer has produced already the 30 products and it has been sent to the block space. Again what happens? The consumer has come into picture and consumer is consuming the remaining products. So now when the when the queue is empty, obviously the consumer will be sent to the wait phase. And until there are some elements in the queue, consumer will not be reactivated. In the same way, when the queue is full, when the product size is 10, producer will be sent to the block phase and the consumer has come into the picture. Okay? This is how a wait and notify model can be used in multi-threaded applications. Understood? Understood everybody? Okay? And make it sure that wait and notify should be executed only from synchronized methods. If you execute wait and notify from non-synchronized methods, then unexpected results will occur. Unexpected results will occur if we execute wait and notify from non-synchronized methods. So make it sure that wait and notify are being executed from synchronized methods. Okay? Now, let me explain it from the top. First, what we are having a class product which is to represent the product, and we have a product queue which is used to represent the queue, and the queue has a collection, okay, collection of products, okay, and we have a maximum queue size, and we have two methods: add products to queue and consume products from queue. Add products to queue will be used by the producer to insert some products into the queue, and consume products from queue will be used by the consumer to fetch the products from the or to remove the products from the queue. And these two are synchronized methods, and both producer and consumer cannot parallelly execute. Both producer and consumer cannot execute this queue at the same time. Cannot use this queue at the same time. Okay. Now, what I am doing is first I am checking if the product size or the queue size is reached the maximum queue size. If the queue size has reached the maximum queue size, then I am sending the producer thread to the block phase. Otherwise, I am notifying the thread and I am adding this to the queue. Okay, and I am adding the product to the queue. In the same way, if the queue is empty, then what I am doing is I am sending the consumer to the block phase. Otherwise, I am notifying the consumer and I am fetching the products or I am removing the products from the queue. Okay, and I have producer thread which has the reference of the queue and which is continuously producing the products, and I have a consumer thread which has the reference of the queue and which is continuously consuming the products. Okay, so even it is continuously consuming the products, okay, the consumer is not active until the queue is full, until the producer releases the lock, and when the producer releases the lock, then the consumer comes in the picture and it is continuously consuming the products. And again, the producer is reactivated, okay, and again the consumer is reactivated, okay, based on the CPU time, okay, and based on the execution of the running phase. Okay, like this the producer consumer model will work. Okay, just Sharath will post this example. Have a thorough look of this and how we can use wait and notify. And another thing, interview question is, if you use notify to reactivate, or if you use notify to send a thread from block phase to active phase, why notify all is used? If we have a shared resource, we have a shared resource and we have a thread associated with this. Let's now select E1 is a thread which is associated to this shared resource. Okay, this is the product queue. Product queue, which is a common resource, and this is the producer. Which is there. Now, if producer is associated with the shared resource, which is the project Q, okay? Now, if we are in certain method add to Q, the current thread is producer. Now, we are sending using wait method to send producer thread to the block phase. And to reactivate which method we are using? Now, to reactivate a thread from block phase to active phase, we are using notify method. And notify is used to send a thread from wait is used to send to block phase. And again to reactivate it, use notify. And why notify all these instruments? What notify will do is notify will reactivate only the current executing thread. Notify will reactivate only the current executing thread. But notify all will reactivate all the threads associated to the shared resource. Notify all will reactivate all the threads associated to the shared resource. Notify will reactivate only the current executing thread, but notify all will reactivate all the associated threads to the shared resource. Notify all will reactivate all the associated threads to the shared resource. Those are the difference between notify and notify all. Otherwise, both notify and notify all are used to send a thread from block to active phase. But what thread is being sent to active phase will be changed from notify to notify all. Notify will send only the current thread, but notify all will send all the threads associated to the shared resource to the active phase. Wait is completed, notify is completed, sleep is completed. And the next concept in multi-threading is deadlock. What is a deadlock? There will be some kind of deadlock situations where let's consider we have a shared class which contains two methods. Synchronized method test 1 and synchronized method test 2. And we have two threads. First thread, second thread. Okay? In the first thread, what we are doing is we are executing S1 dot S1. The second thread we are executing S2 dot S1. Okay? We are sending both S2 dot S1 S1. And this S1 will take a share, and then what we are doing is we are calling Yes. No. S2. S2. And this method also we are calling S dot S2. Okay. Now what we are doing is S1 dot S1 of S2 and S2 dot S1 of S2. Okay. So S1 dot S1 of S2 means what happens? It will be calling S1 method of the shared resource S2. Now S2 dot S1 of S1 means it will be calling the shared resource of. Now both are synchronous methods. Now what we will do? The first thread and second thread are there. First thread will occupy the log of the S1. First thread will occupy the log of S1 and it will execute the test1 of the first shared resource. And second thread will take the log of S2 and it will execute the test1 method of the second shared resource. Now, what happens? Now, in test1, what we are doing, we are calling S dot test2. Now, for the first thread, S dot test2 means which object test2 method we are calling? In the first thread execution, if we are calling S dot test2 here, okay, where it will go? Which objects test2 method is called? First objects test2 method is called or second objects test2 method is called? Just see this. In the first thread I am calling S1 dot test1 of S2. Which reference I am sending here? S2 reference. S2 reference will come to S. S dot test2 means which objects test2 method I am calling? Second object test2 method I am calling. Here in the same way here also, if I call S dot test2 from the second object, from the second thread, okay, which object test2 method I am calling? First object test2. Okay. Now, in order to call the second object test2 method, what happens? The second object test2 method is a synchronous method. But to access the test2 method which is synchronous, do we need to have a log of the second object? Yes. Now, is the log of the second object free or is it occupied? Occupied. So we cannot enter the second object. Now, when the second object log will be released? When the second object log will be released? When the execution of this one is completed. Now, in order to complete the execution of this one, what we need to have? Okay, we need to execute this statement. If we want to execute this statement, what we need to have? We need to have the log of first thread. Am I right? Why we need to have the log of first thread means we are executing the test2 of the first shared object. Okay? Since we are executing test2 which is synchronous, now we need to execute the test2 of the first shared object. Now, is the log of the first shared object free or is it occupied? Occupied. Which is occupied by first thread. Now, second thread should have the log of first shared object to complete the execution. At the same time, first thread should have the log of second shared object to complete the execution. These two are mutually independent. If one happens, then only other thing happens. But both are mutually dependent. Nothing will come out. Just because first thread is dependent upon the second shared object log. But second thread is dependent upon the first shared object log. Okay? Okay? So, what happens in that scenario? No thread will come out from the shared resource. Both threads will be themselves and the execution will be wrong. So, this situation is called as deadlock situation. Understood? Okay? So, to avoid deadlock situations, we should follow better code practices that, okay? The shared resource, from the shared resource, okay? From one of the shared resources, we we should not call the methods of other shared resources which are synchronized. From the shared resources, we should not call the methods of other synchronized methods. Sorry. From the shared resources, we should not call the methods of other shared resources which are synchronized. We should take that care so that we can avoid deadlock situations. From a shared resource, we should not call the synchronized methods of other shared resources so that we can avoid deadlock situations. Understood? What is the deadlock?
When a synchronized method of one shared object is not available to the another thread, and the same scenario happens to the first thread also, because the synchronized method of the second object is not available and both are mutually dependent. So in such case, there is a deadlock situation arises.
And the execution will be blocked. If they are mutually dependent and the lock is not released by both, then in that scenario, deadlock arises. Okay. The next concept in threads is thread groups. Thread groups. Thread groups. Okay, we can make multiple threads as a group. Okay, we can make multiple threads as a group. Now let's consider that I have created two threads, but I want to manage these two threads, multiple threads. Let's not consider about two threads. Let's consider like there are multiple threads, like 10 threads, and we need to manage those 10 threads as a group. If you want to send those 10 threads to the block face, we should send at the same time. If you want to start those 10 threads, we should begin at the same time. Okay? And if you want to manage some threads as a group, then we go for thread group. Okay? How we can use a thread group means, first we need to create a group. Which is the name of the group, which we represent a string which is the name of the group. Okay. Now, while creating a thread, we give a thread group. While managing threads, we can manage the threads as a group. Sending to the block repairs or reactivating or stopping, anything we can do as a group. For that purpose, we have a thread group. Just how we can create a thread group means, we create a thread group object by taking the group name, and while creating the thread, we will assign a group. Okay, now let me try to SRC, clear the screen. Compile the application. Sorry, let me make these implements with runnable. This is the ideal way of doing this implements with runnable. This will give thread group. Both first thread and second thread are a group now. Sorry. We will have a share reference. Okay, just what we do is we create a thread group and we create multiple threads which implements runnable. Okay, and we create the objects to the child thread class and we add them to we make them thread class objects by sending first the group and the child thread object. Okay, first create a thread group. Okay, create child thread objects using the thread group and child thread objects, create a thread. Okay, and add the child thread objects to the group. Understood what we have done? First create a thread group with a group name and create first child thread object, second child thread object, and create threads which contains the thread group and the child thread object. Okay, and start the threads. Okay, that's what we can do. Okay, with the thread groups. And Okay, if you see here, we have stop, suspend, resume, destroy. Okay, and we can add multiple threads to the group if required at the runtime. Okay, and we can set the daemon flag. Okay, if you see here, we have a remove method which is used to remove the threads from the group, and we have set daemon flag. Okay, we have set daemon flag which is used to make all the threads as a daemon threads. Let's consider like we have a group of 10 threads, and if we want to make all the threads as daemon threads, okay, just what we do is we make thread group tg dot set daemon of true. If you make tg dot set daemon of true, then all the threads will be set to daemon. Okay, like that we can change the daemon flag, or we can change the priority of all the threads of a group by using set max priority. Okay, like that we can have suspend, resume, stop. Okay, we can have any methods which allow grouping activity on a thread. We can perform any grouping activity other than start. Threads cannot be started as a group. Threads should be started individually. Okay. Other than starting, we can perform any operation for a thread as a group. Stopping, suspending, resuming, all this can be done as a group, except starting. Starting of threads should be done individually. Okay. So for that kind of purposes, we can use thread group. If you want to represent multiple threads as a group, and if you want to manage the life cycle of the threads as a group, we go for thread group. First we create a thread group object with the group name, and we create child thread objects, and we create the threads by sending first the thread group and the child thread object, and we can manage them easily. Okay. Like this, the thread groups can be used. Understood? We can manage multiple threads as a group using thread group. And the last concept in multi-threading is ThreadLocal. ThreadLocal. Okay. Now let's consider that I have integer I, integer which is number of statements executed. Okay, I have integer value which represents the number of statements executed for the thread. Okay. Okay, just I am setting. Okay, what is the thread name, or else I will set like this. I mean just printing the thread name and the number of statements executed. For the thread. Okay, now let me comment this. This is not required. just we have discussed what is thread group. Okay, let me remove this and let me make it a simple thread. I am creating two threads on the same child thread object. I am creating two threads on the same child thread object, and I am setting the name. One. I am setting the name as 1 and 2. Okay, and I am starting the threads. Okay, just I am setting the names of the threads and I am starting the threads. Understood? So now what I am doing is I am creating one child thread object. For the same child thread object I am creating multiple threads. Okay, and I am setting different names for different threads and starting different threads. Okay, now in the run method what I am doing, I am iterating the loop for 1000 times, and each and every time what I am doing is I am executing the number of statements executed. Just I am verifying at this point in time what are the number of statements executed by this thread. My intention is to print the thread name colon the number of statements executed by the thread at that particular point of time. Okay, now let me see what happens. Let's compile. Let me go to the classes. Let me execute the application. Now, let me see what happened here. Now 1 is executed for the first time, that's fine. 2, 3, 4 up to 9. 1 is executed for the 6 times. But if you see 2, again 2 is executed for 6 times. At this point in time, is the second thread executed at this point of time or at this point of time? Is the second thread executed for 6 times? At this point of time, it is showing that the second thread is executed for 6 times. Is it true? No. At this point of time, it is telling that the first thread is executed for 7 times, but it's actually executed only for 6 times. Why? Why this conflict occurred? Why this is it a correct behavior? First of all, is it a correct behavior? No. Why this conflict occurred? It's not because of thread safe. Can we make attribute thread safe? See, even if there is synchronization, the synchronization will come into picture if we are using a shared resource. Now, are we using a shared resource here? No. There is no concept of shared resource. Can we have a concept of synchronization? No. If multiple threads are using the same object, same shared resource, then only the synchronization concept will come into the picture. Okay? Here there is no concept of synchronization. Now, why this situation occurred? What is the problem? See, why the second thread is showing as 6 where it should show as 1. Am I right? Here at this point of time, should it show as 1 or 6?
1.
Definitely it should show as 1, just because it's for the first time second thread is coming to the picture. If it is for the first time second thread is coming to the picture, why it should show as 6? Is it a correct behavior? No. But why this situation occurred? What is the problem? The problem here is just because both the threads are using the same child thread object, and the child thread object has number of statements executed which is common to both the threads. Now, is this attribute common to both the threads or specific to a specific thread? How can you tell that it is specific?
You are asking in this problem.
In this application, okay, is this attribute common to both the threads created T1 and T2, or is it specific to T1 and T2? It's common to both the threads, just because the child thread object is common to both the threads. The child thread object is common to both the threads. Obviously, this attribute is also common to both the threads. It's not specific. But since just because it is common, it is behaving in an unexpected manner. To avoid this situation, we can have attributes that are specific to a thread. In an object, we can have attributes that can be specific to a thread. In an object, we can have attributes that can be specific to a thread. Okay? Now, how we can achieve them? How I can go for some attributes which are specific to a thread means we have a class named ThreadLocal. In the java.lang package, we have a class named ThreadLocal. Okay, this ThreadLocal will be used. This ThreadLocal will be used to set a localized value for a thread. ThreadLocal is used to set a localized value for a thread. Now what we do is, rather than making it int, I am make it as a ThreadLocal. So, there in the ThreadLocal we have two methods. One is set and get. Set is used to set the value to the ThreadLocal. Get is used to get the value from the ThreadLocal. Another method, remove, is used to remove the value from the ThreadLocal. We have three methods that are useful in the ThreadLocal. One is set, used to set a value through the ThreadLocal. Another is get, to get the value from the thread local. Another one is remove, to remove the value from the thread local. Okay, so we use set and guess in most of the scenarios. We can set any value. We can set integer value, we can set an object, we can set a collection, we can set any of the object to the thread local. It's not like we can set only integer values or primitive values to the thread local. We can set any object to the thread local. We can maintain any object as a thread local. Okay, let's consider like we have a list of countries which are specific to one thread. So we maintain that list of countries in thread local, so that will be available only to the thread, so that we can maintain any object in the thread local. It's not an integer value or it's not only a primitive value. We can maintain any of the object in the thread local. Okay, now I'm setting the value as I to the thread local. Now I'm printing the value of the thread local. Okay, now let me see what happens. Now number of statements executed, it's not an integer value, it is a thread local which internally contains an integer value. Okay, now let me see what happens. Let me clear the screen. Let me compile the application. Let me go to the classes and let me execute the application. So what I'll do is, after getting it, just I'll execute the get method. To get the value, just I'll execute the get method of the thread local. Now if you see here, the value of 1 is started from 1. 2 is also started from 1. Okay. Now, are those two objects using the same thread local object or different thread local objects? These two threads, T1 thread and T2 thread, are these two threads using the same thread local object or different thread local objects? Same or different? Same. These two threads are using the same thread local object, but the same thread local object can have different copy of values for different threads. The same thread local object will have different copies of values to different threads, and internally in the JVM it will maintain a tabular kind of structure. Thread ID 1, this is the thread local value. 2, this is the thread local value. 3, this is the thread local value. That kind of tabular structure will be maintained internally in a JVM for thread local. So each and every thread will have its own local copy of values. But for multiple thread local objects will not be created. That's for sure. For multiple threads, multiple thread local objects will not be created. Okay? The same thread local object will have multiple copies of values of multiple threads. The same thread local object will have multiple copies of values for multiple threads. Okay? Different threads will have different values in thread local. But the thread local will be the same for multiple threads. Understood? The same thread local object will have different copies of values for different threads. And internally, it will maintain a tabular kind of structure against to the thread ID. The thread ID will be unique, right? The thread ID and the corresponding value for the thread local. Like that, it will maintain a tabular kind of structure. So that each and every thread will have its own local copy. Okay, so first thread will have 1 and even second thread starts from 1. Okay? Understood? This is how the thread local works. Understood everybody about thread local? Got the clarity? Yes or no? Yes or no?
Yes.
Just speak out, man. Did you get the clarity of thread local, or still do we need to discuss about it once again? Understood? Each and every thread has its own local copy if you use thread local. But multiple thread objects will not have multiple thread local objects. The same thread local object will have multiple copies of values for multiple threads. That's what the concept of thread local is. Understood? And this will complete multi-threading. And in the next class, we'll discuss about internationalization. What is internationalization and how and why we need to perform internationalization, and mostly we internationalize dates and numbers. So first we see how we can use dates and numbers in Java applications, and then after we'll see how we can internationalize them. Okay, usage of dates is a very important concept. In any software applications you should use dates for sure. Without dates there will not be even a single Java application. Okay, at least we need to maintain a log when the user has logged in, when the user has logged out, when the user has performed this operation, when the user has done this. Okay, what should be the deadline? Like those kind of things will be performed by dates. So dates concept is a very important concept in Java, and we use dates in any applications. But unfortunately, dates are less asked in the interviews. Okay, but it's very important while we develop the application. So first, we discuss how we can go for dates and calendars, and then we'll discuss how to internationalize them. Okay, that will be the next class. Once the internationalization is completed, we'll go with collections, and once the collections is completed, we have the last concept, which is file handling and serialization. Okay, once that is completed, and we'll move over to the database connectivity. Okay, and then to Hibernate. Most probably within 10 days I'll complete up to file handling. At least 10 days and even 2 more days. Let's consider 2 weeks. Within 2 weeks we'll complete up to file handling, and then it will take at least 4 days for JDBC, so that within 20 days JDBC will be completed, and within another 10 days we will start Hibernate and we will complete Hibernate. So within the next 30 days our plan is to complete Hibernate. Let's hope that the plan will work and we can complete Hibernate by the next 30 days. Okay? And tomorrow is a holiday for you, right? Is it a holiday for you? Tomorrow? Yes, right? No? We? On a holiday? Definitely holiday will be there for any organization. Even a software company has a holiday. If a software company has a holiday, means any organization will have a holiday. That's for sure. So we have a class from morning to 6 to 8, as well as we'll try to complete internationalization tomorrow itself at any cost. Okay.